In this lesson, we're going to look at plugging in some numbers to get a feel for some typical values and to make calculations for the amount of time it takes to reach a certain current level. So in this example, we're looking at the time it takes to be almost right at max, so 99%. So we're right up at our maximum current. How much time does that take, given that the inductor, the solenoid itself, has a self-inductance value, 3 times 10 to the minus 3, so we were given millihenries here. Please make sure you're working in base units. For these calculations, our 50 ohm resistor is our R value. We are given a 12 volt battery, and again, we are asked how long after closing the switch does it take that current to get to almost its steady state value, so we're within 1% of that steady state value. Well, we know the bracketed term represents our percent to Imax, so we're going to set that bracketed term equal to 0.99, and then T is our only unknown, so we just have a little bit of algebra to do, and we can talk then about time constants as well. So we have to be a little careful with our negatives. So that say a little bit of algebra, but we do have to be a little bit careful. When the 1 comes over, we get minus 1 plus 0.99 gives us minus 0.01. The negative here remains with the E, so we lose both of those negatives, but when we take the natural log of both sides. Remember, natural log is base E, so when we let natural log operate on both sides, natural log of 0.01, remember we lost the negative from above. Now, we bring in another negative, however, because the negative up here is the negative I have highlighted here. The natural log of 0.01 is actually negative 4.6, so those negatives take care of each other, and the time it takes to get to 0.99 is 2.7. 6 times 10 to the minus 4. Now, notice our time constant, which I kind of glossed over at the beginning, but we were given the L and the R. So time constant is L on R, is the 6 times 10 to the minus 5 seconds. If we wanted to know how many time constants we were looking at to get to 0.99, well, we really have the answer in front of us. So the time constant tau is on the bottom, right? So that's our 6 times 10 to the minus 5. The T we just calculated is this bigger number, right? 7.6 times 10 to the minus 4. So the 4.6 that we get here represents our number of time constants, right? So if we take this number divided by 1 time constant, it's 4.6 time constants. So that's about what we're looking at in terms of just ballparking it. You want to be in around 4 to 5 time constants to be at your maximum current. Your steady state current, in this case, remember, is given by Ohm's law, where the inductor is now just part of the circuit. It's just a wire in the circuit. So the maximum current through the circuit is based on the resistor only, Ohm's law, so the current is voltage divided by resistance. In this case, our steady state current is our 0.24 amps. So here we have just a nice little short example where we've plugged in some numbers and you get to see how to handle a time constant and the amount of time it takes to reach a certain percent to Imaxed.